So we're starting a new chapter today which talks mainly about inequalities, and we're going to start from the very beginning by solving inequalities using addition and subtraction. Now what I have in front of you is an inequality of a true statement saying that 3 is less than 7. We know that to be true. Now by addition, when we had an equation, we could add the same thing to both sides and thus maintain the equality of the statement. Let's see if that's true for an inequality. If we take the true statement 3 is less than 7 and let's say add 2 to both sides, then we end up with the statement of 5 is less than 9. Well, it seems that addition holds true for inequalities. In other words, we can add the same thing to both sides and still get the same inequality back. Let's see if subtraction works. I'm going to take 3 and subtract 5 and see if that's less than 7 subtracting 5. So we end up with negative 2 is less than 2. That's also a true statement. So both addition and subtraction must hold under inequalities. So what that says is we can add or subtract the same thing to either side of an inequality and still end up with a true statement. So we're going to solve these two inequalities. I have x plus 10 is greater than or equal to 18. I'm going to subtract 10 from both sides of the inequality. This leaves me with x is greater than or equal to 8. If I want to graph that on a number line, I'll just draw a line here, throw down my number 8. Now, if I want to represent numbers that are greater than or equal to, I'll make a closed circle at 8, and then I want all the numbers bigger than 8, so I'll draw an arrow moving to the right and going forever. In this example, I have x minus 22 is less than negative 50, so I add 22 to both sides, which leaves me with a negative 28, and x is less than or just less than negative 28. So the difference between these two graphs is as follows. Here's my negative 28, and I just want to show the numbers that are less than 28, so not including. If I don't want to include, instead of an open or a closed circle, I draw an open circle at the 28, and I draw all the numbers that are less than that. So those are the numbers going to the left. But again, the distinction is equal to as a filled-in circle, not equal to as an open circle. Let's do a couple more. Now, you'll notice in both these situations, we have variables on both sides of the equation. And for today, and probably today only, I'm going to ask you to do this. Anytime you have variables on both sides of the equation, we are going to try, when we add and subtract, to keep our variable term in the end positive. So in order to do that here, I must bring the 5x over to the other side by subtracting 5x. That way I have 6x minus 5x is equal to x, which is greater than or equal to 9. There's my solution. If I want to graph that, here's my 9. It's included, so I fill in a circle, and greater than 9 moves to the right. In this case, since I want to keep my x term positive, I have to subtract 6x to both sides. This gives me 0 here and 4 plus x on the left side. And now I'm going to need to get x by itself, so I subtract 4 to both sides. And x is greater than negative 4. Well, here's negative 4. Once again, this is my algebraic solution. My graph, since I can't include the negative 4, open circle at negative 4, and I need to be greater than, and those move to the left. Once again, I have variables on both sides. I need to keep my variables positive, so I'm going to subtract 4x to both sides, and while I'm doing that, I might as well add 18 to both sides. So I get x is greater than or equal to the total of negative 15. Once again, algebraic solution. Here's negative 15. it could equal 15, so I'm going to fill in that circle, and greater than moves to the right. Here's a word problem. It says 4 less than twice a number is less than 3 times a number. You'll notice we've got two expressions that say less than in the problem. But that doesn't necessarily mean I have an inequality sign each time. In fact, is the word that's going to help us write an inequality. If I say 4 less than twice a number, I'm talking about 4 less. So I'm talking about subtraction. Twice a number, we don't know the number, so we're going to call that x. And that term is less than. So if it's less than, the smaller part of the inequality is pointing towards that term. 3 times the number. So that's 3x. And now we're going to solve that. Once again, keeping our variable term positive, we subtract both sides by 2x. I get x is greater than negative 4. Here's my negative 4. Since it's strictly greater than, open circle, and greater moves to the right.